So we're in the middle of kind of a complicated problem with example 10. So I want to just recap what we did real quick. We talked about tossing a coin and a six-sided die. We assumed they were equally likely. We figured out the sample space size. Then we figured out the tree diagram. We figured there were 12 outcomes possible. We assumed that the classical probability is 1 out of 12.0833. All right, then we went and did it ourselves. Now you could do it at home with a coin and a die, but we were actually going to use, oops, not YouTube, StatCrunch. So we listed all the outcomes, right? So if you wanted to say this is really the sample space, then this is the individual, you know what, I'm going to actually relabel this and you should too. First individual toss, okay? So there's the first individual toss. This is the first, I'm going to, you got to do backspace and get rid of all of this. Then this is the first class sample. Now, of course, we didn't have a class. We were just imagining class sample. Okay. This thing is totally can be ignored. So we're not, I'm just going to delete that. Oops. If you want to do it quickly, just highlight all of them. Here, hold on. Highlight all of them and just go to edit and you can cut and they're gone. All right, then this was in order. Oops, I'm not sure what it did there. In order, the first class sample. Or here, let's put it this way. First sample in order, right? If you want to change your width, by the way, you can make it so that, for example, I've auto-sized columns to fit my values and say OK. And there, that way I can see things a little bit better. And actually, I'm going to cut. Oops, delete. Delete that column. I want to delete variable 2, and actually I want to delete variable 5. I'll delete those two. So there we are. Now we're in order. Now everything's looking good. All right, so I've got my outcomes, got my first toss, got my first class in order. All right, now we're going to do it all again. Okay, so then we went back here. We said, okay, that's what we got. Then how many were there in the class overall? So that's why I had to put them in order so I could see, oh, there's 3 of them right there. Okay, and then I said, okay, out of 30 trials, right, my hypothetical class of 30, that was 3 out of 30. Now, that's the difference between empirical and classical. Our classical probability was 1 out of 12. Everything was hypothetical. We just assumed all the outcomes were equally likely. For the empirical, we went and actually did the data. We simulated it by computer. I mean, if you're in a face-to-face class, you can do the actual experiment. And then you record the outcomes from that experiment. Now, there's the difference between classical and empirical. Now, the question becomes then, are all the empirical probabilities going to be the same? I mean, classical will be the same no matter what. It's 1 out of 12. But what about empirical? So we're going to repeat the experiment. So we're going to go back to StatCrunch. And yes, you're going to copy and paste this when it's all done into Excel. So we're going to name this the second individual toss. And I think I just put a capital N in there. I don't want capital N. There we go. All right, let's see if it'll actually put it in here. I've never done this before. So data, I want to sample my columns. I want to sample the outcomes. I want a sample size of 1. It can stack it, that's fine. Whatever. Oh, it looks like it's just going to put it into whatever column it feels like. All right, fine. Now let's say sample. There it did. It threw it into that. I don't know why it's putting it in there. Oh, it's because I did the stacked thing. Well, I can just delete that. And then I'm going to make this name this guy, and I'm going to delete this column. Edit, columns, delete it. Variable 5, go away. There we are. Cool. All right, so now I've got my second toss. That cannot be. Oh, man. I don't want H1 again. That's boring. I'm going to do it again. I know it's breaking all the rules, but sample columns. I want to sample my outcomes. I'm going to sample with replacement. That's fine. I want a sample size 1. Aha! Now we're getting somewhere. Now we're doing something different. There we go. Alrighty then. I've got my individual toss right there, T4. So I'm going to go back and put that in here. I got T4, this guy right here. All right, now I'm going to have to do another round of the class. Oops, you don't need that. Not yet. All right, go to Data, Sample Column. There it is. I want to sample the outcomes. I want 30 numbers of samples. I only want one. Sample with replacement. I want them stacked. And I don't care about any of this. All right, let's do it. Sample column. There it is. And it keeps moving it farther to the right, but that's not a big deal. I'll just delete columns. Columns, delete. I'm going to delete both my variable 7s and that sample thing. I don't need that. There we go. Now I do want this in order because I can't tell which ones are H1 out of this. So I'm actually going to relabel this. This was the second class sample. Okay. Oh, I love this width thing. That was great. How did I do that again? Columns, widths. Right in there. That was wonderful. Makes it so that they're the same size. I'd forgotten about that. All right, so then data, sort my column. And I want to sort that second class sample. And I want it in, I don't really care about the order. I actually want it in ascending order. And that's done fine. I'm going to say sort columns, and there it is. Close that. And this is going to be second sample in order. All right, there we go. And now I can see this time I got 4 H1s. Right, so I'll go back. Whoop, not there. Actually, all right, so there were 4 of them total out of 30. So the probability was 4 out of 30, which I don't know what that is in a decimal, but now it's about time we copy all of this. So I'm going to take my mouse, I'm going to drag it down. I'm going to get all the samples, everything great, everything labeled well. I'm going to go to sheet 2. I'm going to label it 5.1 example 10. I'm going to go in here and paste it. So there it all is. Double click to make my, there we go. So if you just go to all these and then double click, make it do that double-sided arrow and double click, it makes them all the right size. All right, so my probability for part A, there we go. So for part F, it was 3 out of 30, which we knew was 3 divided by 30. There we go. So for part, which part are we on now? There we go. Part J, I want 4 out of 30, so I'm going to do it right here. J, this is equal to 4 divided by 30, which is 0.1333. Going back, 0.1333 repeating. All right, now compare the probabilities. Are they the same? Well, give me a second, I'll type that up. Okay, so the probability in F was 0.10. The probability in J was 0.1333. They're not the same as each other, but they should be close to each other, right? As long as you get a nice random sample. They should also be close to the classical probability of 0.083333. And they are. It's not like, this isn't 0.9333, it's 0.1333, which is pretty close to 0.08333. Alrighty, now consider both trials. You don't have to do any more with StatCrunch. You're just going to consider both of them. How many H1s were there in total for both? That's 7 because we had 4 on the second one and 3 on the first one. So that makes a total of 7. We had 60 total because we had 2 trials of 30. Now what does that make? I'll go back to Excel to do part N. I better highlight these because these are, actual answers that we need. Boom. All right, so N is 7 divided by 30, or excuse me, 60, which is 0.1666, 11667. Back. There we go. 7 divided by 60, which is 0. I already forgot it. 116 repeating. There we go. Okay. I'm just putting in the decimal places. It's easier than going to get the other thing to put the bars over them. All right. There's our total results. Now, if the class repeated the experiment over and over and over and over and over, and if we did this with our with StatCrunch over and over and over, and we kept tallying the total results, what would we expect to have happen? All right, there we go. If we did this over and over and over and over again, then it should get closer. The probability that the results should get closer and closer and closer to 1/12. 1/12 is the classical probability. It's what it should be. But then your empirical data is what actually happens. And then if you keep tossing more and more and more, then this number will transform into something closer and closer and closer to this number. That's called the law of large numbers. It's saying that as repetitions of an experiment increase more and more and more, then the probability observed, i.e. the classical probability, the empirical probability, the probability observed, gets closer and closer and closer to the classical probability, the probability of that outcome. Now, what are the implications of this for the gambling industry? Well, if you've ever been to a casino, this is why casinos have no clocks or windows, right? And if you are, just as you're thinking about leaving, they have free drinks, right? They offer you coupons for restaurants and stuff that's in the casino. In Las Vegas, in the Strip, you can actually walk from casino to casino without ever having to go outside. Why? Well, because the longer they keep you there, the more money they make. So even if you were up for a little while, in the long run, the law of large numbers says that they will win out. And there's several really interesting radio shows and podcasts about this, one of which will be most likely on the discussion board for you to talk about if you're in the online class. All right. Now, let's pause right there, and we'll come back and do the last video, which will be on simulations. So I'll see you then.